Okay, so hi everyone. I believe I'm audible and visible to all of you. Please confirm in the chat so that we can start. So today we are going to talk about a very, very important chapter in a practical manner, by the way. Okay, so let's start. So let me share my screen and start with the discussion. So guys, today what we are going to see. So today we'll be like looking at end-to-end like infrastructure configuration, infrastructure deployment in our local system as well as in a AWS cloud platform. So far we have talked about basically Kubernetes, we talked about a Docker, we talked about GitHub, we talked about basically Terraform, I believe, last week itself. And yes, so this discussion is going to happen based on that, plus lots of addition into a same discussions. So let me open up my Scribble link and then let's talk about a deployment in theory in a first place. So there is a type of the deployment called as blue-green deployment. Blue, green deployment. And this is a kind of a deployment we are going to do. This is something that we are going to discuss in theory, plus we are going to look at it in a practical manner as well. And here, so we are not going to use just one or two stack, but we will end up using so many, literally so many stacks over here. And yeah, so we are going to even look for the automation, basically. So in general, if I'll talk about this blue green kind of a deployment, so this blue green kind of a deployment you can try to understand in a manner that, let's say if I'm trying to build a product, right? So obviously I'll try to release a new version, new feature, each and everything on a regular basis. So here what it does, this blue green deployment, so there will be a blue line and there will be a green line. There will be a blue line and there will be a green line. Now, blue line, let's say this is my production line, so which is basically pointing out to my end user. So where my end user will be able to access something, or maybe I'm trying to host some sort of a API. And then this green line is going to be a temporary prod, you can say. So what happens? So whenever you are going to push a new feature, so it is going to build, let's say, a new image, a Docker image. It is going to build. In both the cases, there will be Docker image, let's say, right? So we have an image over here and we have an image even in this particular place. So now, so blue line is trying to serve to a production and eventually to a user, right? End user, it is trying to serve. Now here, what will happen? So whenever I'm going to push a new feature, so eventually it is going to build a new image, and that will not go for a direct deployment. Means that is not going to face a current user. A reason is very simple. So let's say if I have made some sort of a mistake, or not a mistake, I would say, if build is going to fail or something is going to happen, right? So this is pointing to my end user, and my API system will be down, my front end will be down, my middleware will be down, or whatsoever I'm trying to serve or cater. So that is going to be down. And then in that situation, so my end user is going to face a certain of issues, and there will be a downtime. Now, so this is the reason. So we try to choose for this blue green kind of a deployment. So what we do, so instead of sending this, this the entire image, a fresh image that we are going to build with the new feature into a blue line, so we try to send it to a green line, right? We try to send it to basically a green line. And here inside this green line, we are going to push it. We are going to basically test it, and then we are going to confirm that okay, everything is up and running. And then by using a mechanism, what mechanism I'm going to tell you, there is something called as AWS code deploy, which is going to manage each and this blue and green line for me. So with the help of that service, so which is going to switch the container or switch the image. So we are going to make this green line to a blue line. That okay, fine. So or you can say that we are going to send this image to this one by using that particular services, and then this will start serving or to the end user, or this will start getting a traffic from the end user. And then we are going to keep this green line alive for another 1 minute, and then we are going to destroy it, because ultimately it's a Docker image, so unnecessarily we don't want to occupy the spaces and the process. So this is what happens in general with respect to blue and a green line. So in definition, is it clear? So what we are going to discuss in terms of deployment. So likewise, there are so many different kind of a deployment. You will be able to find out there is something called as canary deployment. Yeah, so there are so many out there. Okay. So we have basically this blue line and basically we have a green line. Now, so many things happens over here. So see, building a product is not just about a deployment, I would say, but many things comes in between. So it's also about, deploying it in a secure manner. It's also about, do not disturb a user kind of a things. It's also about maintaining, managing, monitoring, logging. All of these things comes into picture whenever we try to talk about this, and in between multiple services comes into picture. Yeah, multiple service basically come into picture. Here will be zero downtime, absolute zero downtime user is going to face, yeah, in this particular situation. Now, so here basically what we are going to do in this entire things that we are going to discuss about is that let's say user is going to come. So let's say I have a user, right? I have a user. So user is going to come. And then basically there will be ALB, application, load balancer. Basically, this will come into picture. Now, what this ALB does, so as we all know that we are running two things. So we are running a blue line or blue version, and we are running green version. So far, ALB will be pointing to a blue version. So by default, whatsoever traffic, because at the end of the day, ALB is the one who is responsible for receiving a traffic, right? So every hit, every traffic, ALB will be receiving over here. So it will keep on sending those traffic to a blue line, right? So whether it's a blue line or whether it's a green line, in both the places, there will be a container. So for example, if I'm trying to use AWS services, so as we all know that inside AWS, there will be ECR and there will be ECS. So ECR is for registering our images and then ECS for running that particular images. So here in terms of like a ECS, so there will be ECS container will be available. And even over here, so ECS container will be available. Fine. Now, so green line is a temporary line. Like I have already mentioned, green line is going to be a temporary line. So green line is just been used for a swap purpose, and that swap will be done by a code deploy. So there is a service in AWS called as code deploy, and that service is going to handle this blue green one. So in my code, I'm just going to configure it. That's it. Apart from that, I don't have to do anything. Now, once this blue line basically will be like a live. So once new container will be live, so obviously it will start serving from here, and then eventually what we are going to do, so we have to even monitor, right? We whatsoever services that we have deployed, so we have to even monitor. We have to monitor CPU utilization, we have to monitor basically memory utilization, we have to even monitor like all the logs which will come in between, and then if something will go wrong, so obviously we have to send a alert as well. So if I'll talk about AWS, I'm just talking about AWS deployment, right? Over here. So if I'll talk about AWS, so in that situation, there is something called as CloudWatch. CloudWatch as a service that AWS has already given to us. So we can try to use a CloudWatch over here. Now from CloudWatch, so we'll be able to get Cloud, CloudWatch, metrics, and dashboard. Dashboard. And then from here, so there is another service called as CloudWatch alarm. So I will be able to generate alarm in terms of I can send an email, I can send a SMS, I can configure all of these kind of a alarm. So again, this is one of the services which is available inside a AWS, right? So email alert, I will be able to send. Now, this is the kind of a situation comes into picture. So whenever we have a AWS kind of a deployment. But same thing, let's say if I'm trying to do it in my local system, so I'm trying to not using this AWS by the way. So what I'm going to do, so I will be basically using, you can say, like a local system, and inside a local system I would like to replicate the exact same thing. So obviously in local system I won't be having ECS, so obviously I will be running each and everything inside my local Docker container. I won't be having CloudWatch, I won't be having CloudWatch metrics and dashboard service, I won't be having CloudWatch alarm services, so I won't be having any of these services. So if I'm trying to run something in my local system, So what I'm supposed to use, how I'm supposed to use, and how I will be able to maintain and manage each and everything in my local system. That's another question for me. So let's try to understand. Yeah. So let's try to understand. So basically in a local system, how it is going to happen, how it is going to work. So replica of the same. So here, let's say there is a user, yeah, user. So user will come. So obviously user will try to access my application. So my application will be up and running inside my container. Docker container, right? So maybe like my API endpoint is running, maybe my UI interface is running. It can be anything, right? So API endpoint or maybe UI interface, anything I will be having. So and again, so when I say local, it simply means that if something is running in a local, so how you will be able to host it or you will be able to configure it in any other server, right? So where let's say pre-built services are not available, for example in a bare metal or anywhere, right? Or let's say on AWS itself, you are not using any of these managed services, a CloudWatch, Cloud Matrices, or maybe a CloudWatch dashboard, or maybe a CloudWatch alert. You are trying to use just a EC2 machine. That's it, right? You're just trying to use a EC2 machine or even ECR ECS for like a Docker container. And then rest of the services you are trying to configure on your own. You don't want to use. Okay, I think I was on mute. So by using AWS services and by not using AWS services. So here again there are so many like a very famous things comes into picture. So see, first of all, let's try to understand that what this cloud watch is going to hold, what this cloud watch is going to basically receive, or what this cloud watch is going to basically access. So basically when we say this cloud watch, so cloud watch is going to hold some of these matrices which I would like to talk about. Is that in this situation, CloudWatch, so it will be able to hold a matrices. Matrices means so how much CPU utilization you have, basically how much RAM that you are trying to consume. All of these things, it will be able to hold it. Now, so same thing if I have to access by using some alternate services, then which service I'm supposed to use? So here, to the service that you will be able to use to capture a matrices. So here, matrices. So matrix endpoint is basically Prometheus. Prometheus. So Prometheus is a kind of a service which is going to collect a matrix for you at any point of a time. When I say matrices, so like I said, CPU you will be able to capture, memory users you will be able to capture, request per second you will be able to capture, response time you will be able to capture basically with the help of Prometheus, database connection, DB connection, how many times it has been done, so you will be able to capture. So for example, CPU users wise, so my CPU is at 10%, 20%, 30%. Again, memory wise, so maybe 1 GB, 2 GB memory is been utilized, right? And again, in terms of a response time, so let's say this is a 100 millisecond or microsecond request per second, basically like 5 requests per second, 10 requests per second. Database connection wise, so at a time, let's say there are like a 30 database connectivity which is already there. So all of these matrices it will be able to capture. So Prometheus is a kind of a tool, or you can say a software which just capture the matrices. That's it. It is not going to capture anything else. It is just going to capture the matrices. Okay, matrices in terms of all of these things. Now, along with this matrices, I would also like to capture my log. Log means so whenever some software is running, so obviously it is generally in local system. What do? We do a print statement, right? So that we can see what is going inside, the application. So I would like to capture a my custom log as well. So which I would like to produce from my application. That okay, user have logged in, user have done the payment, user have accessed this particular course basically, or user have used this particular services. So all of these are not a matrices, it's my custom log. So I would like to capture that particular log as well. We can say that as a application application log over here. Now, Prometheus will not be able to capture that particular point. Prometheus has been designed to capture these default things, right? These default things from your Docker container or from anywhere you are going to do it. So here, what will happen? So let's say I'm going to store everything inside app.log file in a local system, app.log file. Now from here, so there will be something called as basically a promtl, right? Promtl, so which is going to pick this particular log, right? Which is going to pick this particular log, and it is going to send this log inside a tool called as Loki. Loki, Loki, right? So Prometheus is capturing a matrices, and then with the help of this promtl, so I'm trying to pass this log to my Loki. Now, both of this, Loki and this Prometheus, is trying to produce something valuable for you. And I would like to see all of these things in an amazing manner. Amazing manner means so graph, dashboarding, and all those things, right? So all of those things I would like to look into it. So what I will do for a dashboarding, so there is a tool called as Grafana, right? So Grafana is a very famous tool. Prometheus is a very famous one. Promtl is a very famous one. Loki is a very famous one. So I'm going to configure basically a Grafana. And what Grafana is going to give me? So Grafana is going to give me a beautiful dashboard, maybe by using a pie chart, maybe by using something like this, right? Whatsoever way I would like to configure. So I will be able to configure all of these things over there, right? So this is something that you will be able to get it from a Grafana. So Grafana is basically a tool which helps you out in terms of creating a dashboards. So just like Power BI table, you can think, right? But for a log and matrices. For log and matrices, this is something that it is going to do it. So you will be able to get a beautiful dashboard from a Grafana, by the way. And then you have to send alert as well. For example, in case of AWS, so we were using what? CloudWatch alert we were using. So here, what we can try to do, so to send the alert, so there is something called as alert manager we can try to use, and we can configure over here like email, Slack, we can try to configure WhatsApp, Telegram, that we can try to configure Teams, we can try to configure SMS, we can try to configure. So in this way it will keep on sending all of these alerts. So for example here, so we were using basically CloudWatch alert, so we are using basically alert manager in this particular place. So AWS has given you all of these things under CloudWatch service. So CloudWatch provides you logs, so which is going to capture all of those things. CloudWatch can capture matrices as well, which is actually been captured by Prometheus. CloudWatch can give you a dashboard as well, which is actually been done by Grafana, right? In our cases, CloudWatch can help you out in terms of sending an alert as well, so which has been done by Alert Manager. So for all of these alternative services are already available in a managed manner, so where you will go do few clicks and then it's bingo and done, right? So you don't have to worry about anything, and you will be able to get your services, you will be able to run your services at any point of a time. So making sense, guys? Yes, making sense. So what is what? So never get confused. So when we are going to use something, so basically I'm trying to show you this setup, so that tomorrow if you would not like to use some of the pre-built services, some of the managed services from any of the provider, not an option at all. I have an option over here, right? Let's say I'm not using AWS, Azure, GCP, I'm using some other cloud provider, and obviously every cloud provider is not going to give you everything, right? So I have an option. I know the option that I know Prometheus, I know Grafana, I know Promptil, I know Loki, I know Alert Manager, right? I will be able to configure each and everything, and I will be able to enjoy the same service which will be given by in a managed manner. The only difference is that I'm managing it. Managing means what? I mean, like one-time setup. So just like Docker container, I'm going to run, and then everything will be done in a automatic manner. But yes, I will be able to do everything inside my local, as well as I will be able to do everything inside my uh, like a cloud system as well. Making sense, guys? Yes. Okay, now let me talk about a flow, right? Flow of the deployment. So how we are going to basically deploy. Yeah, how we are going to basically deploy. So deployment wise, I will be having my code in my local. Yeah, code in my local, let's say. I will be having code in my local. Now from my local, what I will be doing, so I will try to use a Git through Git. So obviously like local Git and then GitHub, in which I will be sending my code. Now on inside a GitHub, so it's not just one single branch which I will try to maintain. So I will maintain my dev branch, I will maintain my test branch, and I will maintain my prod branch with a certain rules, obviously, right? With a certain rules, I'm going to maintain and manage all of these branch one by one, one by one, one by one, so that it is supposed to behave as the way I need, right? The way I need at the end of the day. So I will be having these three branches basically, and how these three branches are going to work, so that I'm going to define it inside my code. That okay, so whenever I'm going to push a code, so it should go to a development, then it should do a testing, and if that is going to pass, then it should move to a test environment. If it is going to pass, then it should move to the prod environment, and finally it is supposed to deploy itself, right? Finally it is supposed to deploy itself from this prod environment. So basically, it should be able to deploy inside AWS. Inside AWS, I will be using ECR and ECS service, ECS Fargate and ECR for a registry of my container. I'm going to basically use it, and I'm going to basically do it, right? For prod environment, the final one, right? Now inside this one, obviously I will be having a blue and a green, right? So blue and a green deployment. So do not try to push everything inside a blue. So try to even push first of all inside a green, test it, and then if everything is up and running and working, nothing is going to break, then in that case there will be a service called as code deploy, which is basically comes under AWS, right? It's a AWS managed service. So code deployed is going to swap the repo, and then it is going to destroy the green line, right? Because now everything become a blue line. So now what and all steps we are supposed to basically take, that is something that we are going to check. So here, let's say I'm talking about a deployment into AWS. So if I have to deploy something inside AWS, so first of all I'm supposed to do a login, right? So AWS login. So obviously I have to go and I have to create a IAM credentials, and that credential I can try to configure inside my GitHub basically, so that GitHub will be able to access my AWS. So once it will be able to log in into the AWS, and once it will be able to see that services are up and running and available, so in that situation it will start building, right? This GitHub will start basically building like a new images, and then it will try to move from here to here, and then it will try to push it. Now when we talk about this particular flow, so at this particular flow, lot of things you will be able to find out happens in between. So what are the flow of that lot of things that you have to understand, then only you will be able to deploy anything and everything at any point of a time. So let me talk about that lot of things, by the way. So there are so many things that I have to discuss. So here, right? So here, when we say this AWS, right? So when we say this AWS, so inside this AWS, as I have mentioned, that there will be ECR and ECS, and then there will be a blue line and there will be a green line. Let's say both of these applications are running at a different, basically a port number. Now, but before that, so we have to think about this dev, test, and prod. So how things will be moving from dev to test to prod. So let's try to talk about that one, because till GitHub, I'm going to send the code, and inside GitHub, so there are three branches that I'm going to maintain and manage. So here, let me talk about a dev first, right? So dev branch, what will be available inside a dev branch of the GitHub. So here, what will happen? So whenever I'm going to push my code from a local to a dev branch, so it is going to run the test. Now from where the test will come into picture? So obviously I'm going to write a test. So by using a PyTest library, I'll be writing a test, and then it should be able to build the image from a dev branch itself. And here, so it should not deploy anything into AWS in my cloud platform. This is what happens inside a dev branch. Now, so once this is okay, right? Once it is going to pass a test, then what we are going to do? So then we are going to migrate things to my test branch. So we are going to call merge. And then here, so we are going to run tests again. And then we are going to basically build, plus we are going to basically push to deploy. And then here, so when we are trying to push to a deploy, So what will happen? So it will try to push this entire things to my green line. Green line. So let's say my blue line is running at port number 8000. My green line is running at port number 9000. Why I'm allocating a port? Because obviously I need to test also, right? Sometime. So here it is going to call a deploy, but deployment is not going to happen on 8000. So deployment is going to happen basically on 9000. Technically, that label of that deployment is a green line, means this port is not facing to the final user, and then everything is going to be fine. Then what? So then there will be a production, right? Production means what? Facing to the user directly. So here run test, right? Now build plus push is going to happen in a blue green line, and then it will be live on, let's say, 8000 port number. If again something is going to crash, so here we are going to also write auto rollback, right? Auto rollback, because at any point of a time things can go south, and if it is going to happen, so in that situation, so obviously we are going to do a rollback. Merge, yeah. So merge. So this is how, guys, dev, test, and your production branch is going to come into a picture. So dev, simple. So it is going to run the test and build the image, and then it is going to like a merge. There won't be any kind of a AWS over here. AWS will be involved from here to here. Making sense, guys? How things is going to migrate, and what will happen in what step? What is going to happen in dev step? What is going to happen in test step? What is going to happen in the production step? Yes. Okay. So now, so as we know that what is going to happen in a dev step, what is going to happen in test, and what is going to happen in a production step. Now let's try to come one step back. So in a backward direction, we are trying to move basically. So we have started from here, then ECR, ECS, AWS, fine. Then prod, test, and dev, how things are going to basically move. Now let's come one step back again. So when you will try to come one step back, it simply means that you are trying to push a code, push a new code, new feature, or maybe a completely new code from your local to a GitHub. This is what you're trying to do. So whenever you will try to do a push, right? So let's say step number one, push code to GitHub. Now what will happen inside a GitHub? So inside a GitHub, we are going to use something called as GitHub action. GitHub action. Now, GitHub action is going to start itself. And inside a GitHub action, so we have clearly mentioned that, okay, so I'm pushing a code to a dev branch. Now, inside a dev branch, it is supposed to run the test. Very, very simple, right? So I'm talking about this. So now I'm here inside my dev branch. And if I'm inside my dev branch, so obviously I have to run the test over here. So third point is going to be run test in my dev. Fine. So GitHub action will be like a called, and then it is going to run my test. I have written, let's say, my test into my PyTest by using a PyTest library. I have written that. Now, once this is going to pass, if it is going to fail, then in that case, it is not going to do anything, right? So nothing, it is going to send it to the next step, means a testing step. Let's say it is going to pass. If test is going to pass inside my dev environment, then what will happen? So then it is going to check that can I go and log in into my AWS. So AWS login will come into picture. So it will try to do a login into my AWS. Now, once it will be able to do a login into my AWS, then what, right? So then what? And that too in a secure manner. It's not like it should like, showcase a password or anything. So in a secure manner, it is going to basically run it. Then what will happen? So as per my above diagram that I have created, so from dev, so now it will move to the test, and then it will try to basically build an image and will also try to deploy it, but in a green line, right? In a green line, it is going to basically deploy it. So here it will try to build the image. Okay, it is going to build the image. Now, once image will be built, and once this also will be like a tested, each and everything will be tested, then it is going to ask a service called as code deploy in a AWS, right? Code deploy. That okay. So I have already built an image inside my test. And yes, in a green line port number 9000, let's say I'm able to test it and everything is working fine for me. So now do one thing. So basically, you can try to switch, right? You can try to basically switch. So when you will ask, when test environment is going to ask this code deploy to do a switch. So basically, it will try to hand over a task to my application load balancer. So application load balancer will come into picture because that is a guy, right? That is a guy basically who is taking care of this. ALB is a guy, so who is interacting with blue and green both. So basically, it is going to say to LB that okay, so things are working fine. So do one thing, you can try to do one more time cross check. So whether it's a healthy or whether it's a unhealthy. If it is healthy, so in that case, route all the traffic. So whatsoever traffic which is coming to this one, right, as of now, to a blue line. So if it is healthy, so route all the traffic to a blue line. As simple as that, right? As simple as that, it is going to do it. And in this manner, so obviously my user is going to see a zero downtime. Makes sense, everyone? Now what we are going to do, right? So we are going to script each and everything. We are going to basically control each and everything with the help of Terraform. So Terraform is something which is going to help me out in terms of doing a end to end full scale automation, so that write a code once and then forget about everything. You don't have to think about anything. Everything will be up and running and working as per the configuration that you are going to give. So here we will end up using so many different kind of tool systems. So now let's go ahead and let's try to, let me list down what we are going to use in this one. So here, to host this kind of application, so obviously if I'll talk about just inside my AWS, so I need VPC for sure. I need subnet. I'm just talking about AWS because in my local there will be Prometheus, Grafana, Loki, and Promptel. So all of these things will be running in my local. Then you have to configure basically a route table. You have to basically configure application load balancer. So all of these things I'm talking about with respect to a Terraform. So where we have to uh, configure it. Then we have to configure a blue target group. Then we have to basically configure green target group. Then we have to basically take care of ECR repo. Then we have to take care of ECS Fargates, by the way, right? And then we have to even take care of a CloudWatch log group. Then we have to also take care of a CloudWatch application. Sorry, code deploy. Code deploy application. So likewise, so many things you have to take care of, and then you have to maintain and manage each and everything inside your Terraform. So fine, guys, I believe we have a fair understanding about things that we are going to see now. So now let's get into a practical, and let's try to see all of these things in a step-by-step manner. Fine. Any question? Anyone with respect to any services that I have discussed in theory? Blue, green. Explain prod once. Prod means we have like a two lines over here. So if I'll talk about my production, let me rewrite over here. So if I have to talk about my production, so basically there are let's say blue and there are green. Now think in this manner that this is running my image number one. This is running my image number two. So think in this way. If you are getting confused, so in that manner, you can think that this is running one Docker image and this is running another Docker image. Very, very simple. But image one is serving my final user. right? So let's say this image one is running at certain port. So basically image one is technically serving my user. So whenever user will come, the user will try to access my UI, let's say front end, right, website. So it is actually hitting image number one. So basically whatsoever we have deployed, let's say this is deployed in ECS one, and this is basically my ECS 2. So whatsoever is deployed in ECS 1, so technically user will be getting served from there. So now what will happen to this one? So in a green line, so basically we are using a green line for a temporary testing purposes. In that way, maybe you can think. So I'm going to send one image over here. Let's say it is running inside another container, right? So basically inside a ECS2, this image is running. I'll try to run a test on this one. So I'll try to test it. So now if it is going to verify the test, then in that case, what I will do, so I will try to hand over this one to a service called as code deploy. Code deploy. Now what it does, so it just try to do a switching. So it helps you out. It's a pre-built services, by the way, inside AWS. So this helps you out in terms of doing a switch. Means if a user is getting served from a image one, so now how this image two will start getting, or image 2 is going to basically serve my ultimate user. So code deploy, right? Code deploy will come into picture. And here, so what code deploy is going to do? So code deploy is going to call ALB, application load balancer, because eventually application load balancer is sending a traffic. It will be like user will not be able to see anything inside the container. Technically, user will be interfacing to the load balancer. So load balancer will send a traffic to this one or that one. It is completely like authority of a load balancer. So load balancer will do its own check that okay, everything is healthy. So if everything is healthy, do one thing. So with the help of code deploy, swap it, right? Swap it, and then now image 2 technically is serving my user, the end user. So this is how production is going to happen with the help of blue green line, so that there will be no downtime, there will be no error at all. And yes, so user will not be able to see any kind of a bad experiences that's happened inside the blue green line. Now, so let's try to talk about it, right? So I have prepared an amazing example for all of you. Okay. Now, so this is an amazing example which I have prepared for all of you. A very simple one in terms of application. So there is only one web page that we have, and there are the structure that we have created. So let me first of all talk about the structure. So structure wise, this is a place where I have the whole application, right? Whole application, my front end, my back end API, each and everything is available here. So in general, even you will be having whole application in some folder. So my app folder is basically holding all the application. Now this monitoring I have created just for the local, because I told you that I'm going to use a Prometheus, I'm going to use basically a Promptel, I'm going to use a Loki, and I'm going to use a Grafana, right? An alert manager. Also, and if I can try to use it in my local, so obviously I will be able to send it, and I will be able to deploy it on any cloud platform in this entire world, not just on somewhere where things are managed, right? So that's the reason. So I'm going to show you this particular part. So this is basically a local, and here, so I'm going to configure my Prometheus, Grafana, Loki, Promptel, alert manager, right? Each and everything I'm going to configure inside this one, and with the help of this Docker Compose, I'm going to technically run this one, and I'm going to show you, right? I'm just going to show you each and everything. So this is what you will be able to see inside this one. Now come to the Terraform part. So Terraform wise, so I'm going to like I told you that inside AWS will be having so many services starting from the login. So obviously we have to take care of VPC, we have to take care of subnet, we have to take care of basically a routing table, we have to take care of ECR, ECS, code deploy, cloud watch, monitoring, dashboarding, cloud alert, all of these things, right? All of these services. So all of these services, I'm going to write it down as a code over here. So that one call and everything will be created automatically, starting from my GitHub to like a dev test, all of these branches to my final one. And then inside my GitHub, you will be able to find out a GitHub action. So what is going GitHub workflow, by the way. So what is going to happen inside a GitHub, that I'm going to mention inside that particular folder. Then there is something called as test folder. You will be able to find out. So inside that test folder, so we are going to write a test script. That's it. Rest is a Docker ignore. So whatsoever I don't want to send inside Docker, I'm writing it here. So git ignore. So you can ignore this particular part. You can ignore even this particular part, app specification, YAML file. This is one file just for Windows has been created so that in one shot I will be able to execute everything, which I am going to explain. This is a Docker file, basically like which is going to build a Docker image for this particular app, and this is the file that we will be deploying or managing even in local and even on AWS, right? This is the file basically. Now this is just an MD file. Leave this one, 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 and then requirement.txt. This is for development, dev environment, and this is for my production environment. So this is my file format, guys. And yeah, so if you will look at this for the very first time, it looks like a little bit clumsy, but it's not. It's a very clean, neat and clean approach that we are going to follow in this particular one. Do not like worry about too many folders, by the way. Yeah, too many folders. Now, first of all, let's go into app file. Very simple application we have created over here. So if I'll show you my main file, so inside a main file, as we all understands, a fast API, so there are only 3 4 API which has been created. So what are those? So one is a health. So whenever you are going to call this endpoint, it is going to give you a status healthy if your API is up and running, right? So simple health API. Then there is a api.info. So whenever you are going to call, you will be able to see app version, app color, environment, all of these things. Whenever you are going to call this one, basically, so it is going to basically deliberately slow this one. So random.uniform, and then I'm putting that on a sleep basically over here, right? So that I will be able to see the slowness inside whenever I'm going to call this one. So slowly it is going to hit. Now here, so API error. So whenever there will be an error, so I will be capturing from this particular endpoint. So all of these things are basically a fast API. So even inside my slash docs, I will be able to see, I will be able to test it, and I will be able to send the traffic. So this is the only file. Now there is a very simple UI template, a static UI template, which we have basically created. So where I'm going to show you all of these things, let's say. So we are going to show you the things that we are going to get from the api.api/info. This is just calling this api/info. That's it. Apart from that, it is not calling anything. So await and fetch what? So whatsoever is available at api/info, try to fetch it. That's it, and try to show it. Now inside static, there is only a cascaded style sheet. CSS is available, by the way. So just for coloring, font, and theming. That's it. So what will be the body, color, theme, card, all of these things. So this is inside the CSS. So my app is a very simple application over here. It's not at all a heavy one. And inside that, there are only main file, main.py file that I'm trying to use inside this one. Apart from that, I'm not trying to use anything. Now, so this is something that we are using. That's completely fine. But along with that, so in a main file, you will be able to find out that I'm trying to use basically a observability. This is my own file. Now, what is that, by the way? So inside this observability, because as we are going to demonstrate a log matrices, everything, right? Matrices means like a CPU, like a request per second, or maybe response time, by the way, number of DB connection, all of these things, right? We are going to showcase. So basically here we have a observability.py file, and here, so we are trying to call a Prometheus, because in my local, obviously I have to capture everything, and then I have to basically showcase everything. So we are trying to call a Prometheus over here, and here, just the way you do a logging, right? So basically here, so we are trying to create a log in this particular place. So log is we are just trying to create a log over here from my login folder, a login basically APIs, and then we are trying to send this logs, right? So we are trying to basically send this logs to a Prometheus or Promptel. So Prometheus in terms of like capturing a matrices, and the Promptels in terms of like capturing the log. So this is a file which I have created, and here, so just one single method and everything, will be like captured automatically, and wherever you would like to call. For example, inside my main.py file, right? So we are trying to call setup observability app version, app color, environment. So it is basically going to give you all of these things, right? It is basically going to give you all of these things, and wherever I have to log, I will be able to log that as well. So this is where this observability.py file coming into picture. It's like creating a local setup for my log, and then we are trying to like a set a version, color, environment, whatsoever you want, and like a matrices, it is going to log it. So that's the only thing you will be able to find out inside my app folder. That's it. Apart from that, there is nothing which is available inside the app folder. Now, if I have to run the app, right? If I have to run the app, so where I have to come? I have to come inside Docker file. So here, let's after this app, let's come into Docker file directly. So inside a Docker file, as we all understands Docker, so it is going to create an image. So I'm trying to create a small box, Linux box, right? Inside that, Python is already available. Then I'm going to create an app directory the way we do it, right? Then we are going to install requirement.txt inside that particular one. And then we are going to copy basically this app to inside this one. And then here, so we are going to expose that at port number 8000, and we are going to run this app. So run the main file. So main is available inside app. That's the reason we are writing app.main so that I can go from this Docker. From this Docker, I will be able to go inside app, and then inside that app, I will be able to get into main. And then inside this main, so I have basically this app, AWP app, which is my object of fast API. So I will be able to access it. I will be able to execute it. So this is what is mentioned inside a Docker, right? So mentioned inside the Docker. So now once I'm going to execute this one, my application will be up and running. So whatsoever I have written, so obviously it will be up and running. But I would like to run it, right? So my app will be up and running, means my front end and back end will be up and running. But I want something extra, right? I want something extra. So what I want Prometheus, I want Grafana, I want Loki, I want Promptel, I want all of these things to come into picture. So obviously, I have to do a setup for that one. Unless and until I'm not going to do a setup for that one, I will not be able to access all of these services. I will be able to just run a Docker, and then as per my main, so all of my API will be live, and then obviously my UI will be live at that particular point of a time. So I would like to even use my Prometheus, Grafana, and all of these things. And this is the reason. So we are trying to use a Docker Compose so that I will be able to run multiple containers by using a different kind of images. And then everyone will be like connecting with each and every one. And I will be able to like capture the log. I will be able to even show you the logs. Okay, so let's go ahead and let's try to do it. So here we have a service. I mean, like the entire things falls under service, by the way, if you'll go and check this one. Now, inside services, so what and all services we are trying to configure, just like the old days, right? So first of all, we are trying to configure like an app. So basically, app is going to be like a build, and this is going to call this Docker file, this one, right? So this is my Docker file, which is going to be like a blue environment is, let's say, development, and port is equals to 8000. Okay, fine. Similarly, so I'm going to run it for a green, right? So I'm just going to call the same one, same container. I have just changed the port number, as you can see. So green port is 9000 and blue port is basically 8000. So two same Docker file, but running same Docker image, by the way. But when I'm trying to spin that one, so there will be two containers, one container for my green and one container for my blue. Both will be hosting at a different port number 8000 and 9000, by the way. So externally, internally 8000, and then internally means individual container is going to host it. Okay, now what? So basically, we are going to configure Prometheus, we are going to configure Grafana, we are going to configure Loki, we are going to configure Promptel, and we are going to configure Alert Manager. As I have already told you that who is going to do what. As I told you, Prometheus, it works for the matrices, right? So basically, it is going to tell you that CPU utilization, RAM utilization, number of requests, database connectivity, open. All of these things will be shown by Prometheus. So matrix it try to capture. Grafana, it's like a dashboarding tool. So this is going to show you the actual UI interface, right? So whatsoever metrics it is going to capture from here. Loki, so Loki is going to take care of a log. So it is going to store a custom log, right? And then promptel. So Loki is not going to work without a promptel. So promptel provide this to Loki by reading your local logs, right? So it is going to read a container log and then it is going to store that inside the Loki. Alert manager for sending alert. So 1, 2, 3, 4, 5. All of these 5 services, we are going to use it local or anywhere else. So obviously, if I have to use all of these services, so first of all, I have to configure. So what I will be doing for Prometheus, I'm downloading a Prometheus image from a Docker hub. Then from Grafana, I'm downloading a Grafana image from a hub. Loki, downloading the same, right? Promptel, downloading the same, right? Alert Manager, downloading the same. So here you will be able to see that we are trying to download all of these things. So whether it's a Prometheus, right? Prometheus, and then we are sending a profile. Profile means like we can activate it, right? And then we are going to do internal external port mapping. So this is my local system port mapping. This is the internal one, container one, right? And then I'm trying to say that where you can try to mount your volume so that because it has to read something, right? And then from where it will be able to get like a command, and depends upon what, depends upon app. So app should be up and running, then only it should be able to capture the matrices. Same goes for Grafana. So I'm downloading it, right? Profile is this, port internal external mapping I'm trying to do, environment like a auth enable, and then like a volume I'm trying to map for a Grafana provisioning and dashboarding. And it depends upon what, it depends upon Grafana, depends upon, because Grafana is a dashboard, right? So Grafana depends upon someone who is trying to showcase a matrices as well as logs. So basically metrics I'm getting from Prometheus, and then logs I'm getting from where, Loki, right? From Loki I'm going to get a log. So it depends upon both of these services. Unless and until this will not be up, it will not be able to execute it. Then coming to the Loki part, right? So Loki, what? It just store the things. It stores the log, my custom log, by the way, like this person has logged in, that person has logged out, this person has accessed these courses, like that. So here I'm downloading a Grafana image, right? I'm mounting a volume on top of it, and then bingo, done. Promptel. So Promptel is going to help me out in terms of basically like routing a log to a Loki. Loki will not be able to get a log if Promptel is not going to work. So fine, I'm configuring Promptel as well in this one. And then alert manager for sending a alert at the end of the day. So in this manner, I'm going to basically configure 5 different services. Making sense, guys? Can you tell a difference between Docker file and Docker compose? A very sad question, by the way, at this stage at least. Yes, guys, tell me what is the difference between. I think everyone can tell us, right? What is the difference between Docker compose? So Docker is file for one single container, right? Compose means multiple. So in this case, Docker file. So basically, this Docker file is my custom app, which it is going to run. But along with this custom app, I have to run other container as well, right? So I have to container as well. So I'm just trying to use a compose. Inside that, I have written all the services all together. Very simple, right? We have used multiple times, so this is nothing new. I'm not like I have not opened up something which we have not discussed, in detail and in depth. We have already used compose and container so many times till last class even. Yeah. So okay, now this is only required, I would say, for your local, right? Docker file, Docker compose, done. Then the things which is required is basically a monitoring. So how Docker is going to work, how, here we have written, let's say, that basically Prometheus. So how Prometheus will be able to get all of those matrices? Basically someone should say, someone should like redirect, someone should like a help, basically, otherwise it will not be able to do. So those something is available where, available inside the monitoring folder. So monitoring prometheus.yaml, monitoring alert.yaml file. So whenever container will be up, so from my local system I'm transferring this file to this one, right? I'm transferring this file to this one. So here, if you'll come and check Prometheus YAML, right? So Prometheus YAML file, which is already available to me. And here, so I can try to change this configuration. So I'm saying that scrap interval. So I'm saying that, in every 5 seconds, go and check those vitals. In every 5 seconds, I mean, like go and check CPU users, go and check memory users, go and check basically number of requests in number of requests, go and check latency, basically go and check DB connection, all of these things, right? So all of these things. So here it will go and check. Now there is a rule file. So rule file, it will be able to find out from the alert.yaml file. So here you can try to write the rules. right? That for a blue line, what should be the rule? And for a green line, what should be the rule? So you can define your own rule in your own way, by the way, right? So alert rule is what? So alert, it is going to generate app down. So if up, blue app is equal to 0 for 15 seconds. So if my blue line will be down for 15 seconds, it simply means that fire the alert, basically, right? So I can configure this, I can configure as per my own need, that fire the alert, and again label is equal to critical, annotation summary. So this app is not answering to Prometheus, so Prometheus will keep on checking, and as soon as there will be some sort of a alert, so it is going to just fire that particular alert. So in every 15 seconds it will keep on checking. So high error rate alert, so there is a alert called as basically app down alert, the high error rate alert. So when it is going to happen, so summation of rate HTTP request divided by summation rate is more than 0.05%, means you are hitting my server, but server is rejecting your request. Basically, it is not able to basically serve you. So it simply means that something is wrong, right? Something is wrong, maybe overloaded, maybe some application is crashing, something has happened basically. And then if it is going to happen for 30 seconds continuously, right? 30-second continuously, do one thing, give a warning, right? So generate an alert saying that warning. So more than 5% of the requests are returning 5x error, basically 5 series error. So basically like a error it is trying to represent. So this is another kind of a alert that you can generate. Another kind of alert is slow request. So people are hitting, but yeah, so they are not like latency is very, very high. So here again, calculation wise, so histogram quantile 0.9% summation wise rate of HTTP request duration bucket, and then 95th percentile latency is over 500 milliseconds. So, which is like a huge latency. So, in that case, generate again a alert, right, as a warning alert. So, basically, in this alert.yaml file, it's completely under my control that what message to send, when to send, based on what kind of a condition I have to send, and how many different kind of a alert I would like to configure. Everything can be done inside this YAML file. This YAML file will be consumed by whom? This will be consumed by as a rule file inside your Prometheus YAML file. Making sense, guys, how things are connected? Yes? Easy, right? Very, very easy. Yes, everyone in the chat, please, quickly. Yeah, very easy. Nothing big, nothing like, difficult to understand. Okay, fine. So here rule file. So fine, check this one, then alert manager, and then we are going to target the alert manager. So whosoever is going to fire this. So alert manager is up and running at 1993. So basically alert manager is whom? The one which is connected to my WhatsApp, Telegram, Slack, Teams, whatsoever it is, right? Or mail. So alert manager is running on this one. So target that, means send that you should send an alert now. So alert manager service will wake up, and then it will start firing the alert, whatsoever alert that you are going to configure. Simple, right? Job node metrics part, all of these things it is going to do. So scrap configuration. So basically it is going to take all those configuration from where? So it is going to take all this configuration from like a things or app which is running at port number 8000. Okay. So this is all about Prometheus. And when we are composing this Prometheus, so yes, it is taking each and everything from there. So monitoring alert and Prometheus. Similarly, if I'll talk about a Grafana, so monitoring Grafana and then monitoring Grafana, and inside Grafana we'll be having a dashboard. Now this dashboard will be generated, or this dashboard will be populated. So basically Grafana, things we try to write it inside the this JSON file format, right? JSON file format. And then we say that, what we are going to showcase. So blue, green class, blue, green, golden signal, description is this one, tags are this one, time zone, all of these things we are trying to showcase. And all of these data, it is going to showcase one by one, one by one. So whatsoever graph you would like to showcase, you can try to configure it. And provisioning a dashboard. So dashboard.yaml. So dashboard will be created from there itself. Very, very simple. And then what will be the data source? So data source for my Grafana is going to be Prometheus and Loki. Prometheus for matrices, Loki for custom log. Fine. So this is basically a Grafana inside the monitoring. So now when I'm trying to do a Docker compose, so I'm saying that, okay, fine. So go inside the provisioning folder, inside the Grafana and dashboard folder. And then I have given you all the details over there. Same. So if I'll talk about a Loki, so what will be a Loki configuration? So that is written inside the Loki config YAML file. So here Loki config YAML file. Now similarly, right? So basically auth enabled false. So no password is required by the way server. So listen to which port, this port number, log label. So warning. So you have to capture all the warning label log only. This is what I'm trying to say. If I'm going to say that no, try to capture even an info label log, warning label log, error label log. So sorry, if I'm going to set like a info, then below that everything it is going to capture. If I'm going to set warning, then below that everything it is going to capture. So error it is going to capture, critical it is going to capture. I think you understand this log label, which I have already like used to talk about in my Python classes. Okay. So instance address this one file this, and in this way our like entire Loki will be configured. So whenever it is going to spin a container for a Loki, so it is going to use this file and then it is going to basically spin it. Now is that promptel? So promptel is basically for my local. So from local it is going to pick those things. So basically it will go to a Docker, and then from Docker it will try to check all the container log, and then it is going to send it to Loki. So this is what Promptel is going to do. So in the alert manager, so here we have not done anything in terms of alert manager. It's just like we can configure email over here, we can configure Slack over here, right? So receiver. So who is going to receive what? That we can configure inside my alert manager, which I have not done so far, right? So email configuration, and it's very easy configuration, a template, right? Templating configurations. Just bring it over here and then replace that with your email ID and your like a Slack configuration. It will be done. So very easy, within can be done within 2 minutes of time. Okay, so now this monitoring is done, app is done, right? And then Docker Compose and Docker Deploy is done. Now we also know that if I'm creating a container, so how container will be able to get its respective configuration. So means what container is supposed to do, where we have written those things. So we have written those things inside my monitoring folder, by the way. Okay, fine, cool. We have done that inside this one. Now it's time to spin it, right? It's time to basically run it. So here what we can do, so we can try to run this Docker Compose, and inside this Docker Compose profile we have mentioned, and here we have mentioned command as well. So Docker Compose profile build this up. So basically monitor app it is going to run, as well as monitoring stack it is going to run, because everywhere we have given profile is equals to OPS. So now with this is going to work as a parameter basically by you. You can give some other name as well. It's completely up to you. So here with monitoring, I would like to up it, or without monitoring. So without monitoring, if I have to up it in this situation, only it is going to run this one. Even if you're going to not run this one, just run this Docker file. It is going to work. But with monitoring, so just go here and then try to up. So let me open up terminal and then make it up. So now if I'll show you my local Docker, so here blue green, right? And now it is trying to basically up my Loki, up my alert manager, Promptel is up. So one by one, it is trying to, build each and everything will be up in some time. Let's wait for it. Error getting ingest client empty ring. So, okay. Image blue green, attach, alert manager is fine. Port this. Okay, so port is already allocated. Fine. So 8,000 port is telling me that it's already allocated. So where my final this one is running. So I just have to change my port number in a lot of places. So what I will do, I'll just kill the port, because I'll have to make a changes even inside my Docker. So where let me check. Let us start here. It is not able to find out. No. So let me check what is running at. Okay, it will kill the things which are running at port number 8000, let's say. So seems that it has killed, and then once it has killed, let's do CLS. Let's try to do compose once again. Unable to get image, failed to connect to a Docker API at end pipe. This one, check if the path is correct and if the daemon is running. Okay, so another issue. Docker itself, I have stopped. So let me start my Docker. Hmm, fine. Run again. Hmm. Okay, so it is trying to start. It will start in some time. Not started so far. No, blue green, right? Okay, so it looks like Grafana, Prometheus, Promptel, Loki, Alert Manager app, everything is up and running. So now let's go ahead and let's try to check one by one. So what is what and what is like available. So this is my UI interface, guys. Basically, so the simple UI interface. So where I'm just trying to show you the information. So this pipeline is basically blue. Green is for my alternate. Version environment is development container. It is trying to showcase. That's it. The page refreshes itself every 2 seconds. Watch your color flip while a deployment shift. So basically, this page is going to refresh itself in every 2 seconds. Okay, this is one, right? Then this is my actual app, by the way. This is what I have written inside the app. Uh, Not just that, I would say. So here, let's say I would like to show you my Grafana dashboard. So this is my Grafana dashboard, by the way, guys. And here, so anyone can come and anyone will be able to basically like check what is there. So I can go inside a dashboard. I can try to check this blue green golden signal. This is what I have written, right? And then here is my dashboard. So here traffic request per second. So request per second because it is refreshing itself in every 2 seconds, right? So what is a latency, right? Which version is live. So basically, it is coming from my low key error. So far, no data available. So log wise, this is what it is trying to capture, right? Duration, status, path, method, message, this, and will keep on increasing because in every 2 seconds it is trying to refresh itself. So yeah, there are like so many things you will be able to capture every 2 seconds it is capturing it, right? Every 2 seconds. So this is my Grafana dashboard, by the way. This is my beautiful, and I have configured just this much, right? But you can configure so many things, not just like I have configured like 5 6 things over here. So like this one, but you can try to configure many things, right? And it is going to show you the dashboard. So this is my Grafana, by the way. So this is my UI interface and my Grafana, which is able to capture each and everything. I can try to click even before 2 seconds. And yeah, so it is going to show you that particular log, that what is the latency and what is the request that I'm receiving. So see, I have clicked so many times and it has like I have received a spike. So things are working, right? Things are actually working for me. So it is able to store the logs, and from there it is able to generate this one. Everything in my local, and yeah, so in that case I can run like things wherever I want. So here, alerting wise, so I can try to set a rules over here. Alert monitoring wise, rest administration, connection, all these things I can try to control. Okay, so I can populate or I can maintain manage as many dashboard as possible. That depends upon me. Now, so Grafana is up and running. Prometheus, it's just a metrics services which is going to capture your matrices, by the way. So this is where like my metrics is running, and here, so 8,000 it is pointing to, right? And then you will be able to like see the matrices. It's up and running, by the way, right? Yeah. So here, localhost 8,000 matrices. So you will be able to see everything. So whatever it is trying to capture, HTTP request duration, it is trying to capture, as I told you, Python JSON object, uncontrollable access, all of these things it is trying to capture inside this. So this is basically a Prometheus, like a log. And again, so here, this should be localhost, LOCAL. Hmm. Same thing, right? So here we are able to capture each and everything. And from here, so it is going to generate the final graph, which the graph which I'm able to showcase inside the Grafana, right? Here, the graph which I'm able to see it. So fine, this is also live. And then Prometheus, Promptel. So Promptel is basically a bridge between your Loki and your local. So like whatsoever is happening inside the container. So Promptel is trying to capture each and everything. This is what Promptel is doing. Loki. So Loki is finally like basically capturing, storing the log. So it is not going to show you anything. It is storing the log, and then same log I'm trying to showcase inside my Grafana. Alert manager wise, so alert manager it is going to send the alert if I'm going to configure it. So far I have not configured anything. I've just created the alert manager, right? I can even create the groups, and to that group it is going to send it. So everything is up and running, trial and tested. Nothing is breaking at all inside my local system. Okay, so if everything is up and running and working in my local system, so now it's time to send this entire things to a cloud. So AWS, and this is where my Terraform will come into picture. So let me terminate this one. Yeah, so everything terminated. Now everything will be gone. Blue green. Let me delete this. Okay, fine. So now everything will be gone. Now it's time for uh, cloud deployment, and that too with the automation. So any question, guys, from here? I think it was an easy run, right? And we are able to understand what is like a what and what is doing what. Yes, guys, it was an easy run. In a chat, please, if you have any kind of a question from my local run. Okay, so if I'm able to run everything in my local, right? If everything is running in my local, now I have to establish, I have to run everything inside my AWS environment, right? This environment. And this is where Terraform comes into picture. So in my last class, I was talking about Terraform, right? I was talking about technically a Terraform. So now let's try to understand that, how Terraform I'm going to configure. So here there are so many files, but you should not look into so many files. You should just focus on main and monitoring, these two files, right? So one for running the application and one for main and the monitoring. So one for running my application and one for like configuring a cloud watch, because here I'm trying to use a Prometheus, Grafana, Loki, Promptel and alert manager, this five different services, right? Over there I will be using CloudWatch. Inside CloudWatch itself there are sub services, which is like as a replacement of this one. So this is how like CloudWatch managed service is. So I'll be using that one, and I'll show you graph in a AWS as well. Live graph I'm going to show you. So all of these things I'm going to maintain and manage from this monitoring.terraform. Now let's talk about this main.tf. And again, so it's like going to be an amazing one. So initially I told you that whenever you think about configuring, or whenever you think about basically, deploying something on a cloud platform, you have to think about a virtual private cloud. Even if you're going to do it manually, then inside that subnet, inside that routing table, and I believe I have already talked about that multiple times. And then again, ALB, automate application load balancer, right? So all of these services you have to configure. Unless and until you are not going to configure all of these services, it is not going to work, right? It is not going to work. So this is where again I can take a help of a Terraform. The beauty of using Terraform is that I can create one template, and then even in 100 deployment, if I have to do 100 unique deployment, I can do it, right? I can do it. If it is working somewhere, it will work everywhere. So that's the reason. So we discussed about Terraform in my last class, and practically, and now we are going to even use it. So here, what we are going to do. So first of all, you are going to basically, say what is your availability zone. Then again, there is another file, variable file. So variable means, I told you last time, right? So we'll be having a lot of variables. So for example, AWS region. So in which region I would like to deploy? Obviously, it is going to be my decision. What will be the project name? My decision. What will be a GitHub repo, by the way, right? What will be a GitHub repo from where it is supposed to pick the things? So I'm going to give a repo as well over there. Then basically, like, GitHub repo immutable. So this is again a variable which I'm trying to like create, which is immutable means not changeable. Then there is a variable called as container port. So at which port I'm going to run my end application. Desired count, right? So how many, like, container I would like to run. So all of these my custom variable. Simple. You can try to give any other name. That's completely up to you. And I believe I should not teach you like what the variable is. We have already discussed about the variable. Yes, everyone, we know variable. So we have created so many variables over here, and these variables I will be using it. Make sense? Variable. I don't think anyone is having doubt with respect to a variable, by the way. Yeah. So variable is fine. Variable is just like Python variable. I'm assigning some values, which I can use it in a like repeatable manner. Now come to the main. So first of all, AWS variability zone. So it will try to take that one from there, right? Data wise. Then I will try to create a resources, and it's this main file is mostly about a resource, right? So I have created just resource. Now, what is this resource? So anything that I'm going to use, consume, and what are those? So all of this list, all of this I'm going to consume. I have to configure, right? So here, one by one, in this entire file, what we are going to do, so we are going to technically, configure all of these resources one by one. So now let's talk about a block. Okay. So first of all, virtual private cloud. Now tell me what is the meaning of VPC. Quickly, guys, I'll ask you many questions because I have already talked about VPC. What is VPC? What is like, gateway? What is subnet? So quick definition. Anyone who can give me? Yes. What is VPC? So I mean, like, don't tell me the full form. I know full form. I'm asking about a layman definition, by the way. So what do you understand by VPC? Oh, don't expect. So I think people are supposed to be aware about it. So see, I told you when I was talking about this VPC and all those AWS subnet component or like a routing table component, right? So basically, VPC is nothing but your own private box, network box, basically inside AWS. So AWS is, let's say, like AWS is a planet, so it's available everywhere. Now inside that, so I'm looking for a private like a network, so where I can go and I will be able to access certain IP addresses, right? So that I will be able to enable with the help of VPC, Virtual Private Cloud, my own private network inside a AWS, the isolated one which world will not be able to access. I'm accessing AWS. Inside AWS, I have a small box and I'm a owner of that box, basically, in terms of network, right? In terms of a network. So whatever goes inside it and whatever comes out of it, I have a control. Fine. That is VPC, Virtual Private Cloud. So basically network, because whatsoever application you are hosting, you will be hosting in some machine and you have to basically seal that particular machine with a networking policy that this should come in and this should go out. It's not like everyone will be able to hit your production grade database, right? Now, so VPC is one thing. So here we are trying to configure a VPC. So here we are saying that, 10.0.0.0./16. So this is basically like, my masking I have given. So it simply means that 0.0.0, so around 65,000 IP addresses will be available to you. Enable domain name server support. Yes, true. Hostname, true. Fine. So tag, we are trying to give it as a project name. Project name will be coming from the variable. Okay. Now the next one, gateway. What is gateway, by the way, guys? Quick. What is internet gateway? So let me explain you once again. So see, internet VPC you have created means there is a small network, a small box, and now you decide that what will go out and what will go come in. So this is a box, and then you have decided what will go out and what will come in. By the way, now this is my VPC. Fine. Now, so it if it is supposed to connect to a internet, right? It is supposed to connect to a internet. So how it will be able to connect to a internet? Because by default, this is just like my local system, not connected to internet at all. So if I have to connect to internet, so what I do, I connect with the router, right? And then router is connected to the multiple switches and overall the network. So here there will be something called as like internet gateway. You will be able to find out, as its name suggests, so which makes available internet to your VPC. Means now your VPC will be able to communicate with the entire outer world. If you don't want, you can like detag it, or wherever you want it, you can just try to call basically a internet gateway, and it is going to provide you the internet access to your VPC boxes. Very, very simple. Now, so the third thing is, and all of these things are very common. Whatsoever you are going to do it, first of all, you have to configure this one. Then there is something called as AWS subnet. So what is a subnet, by the way, guys? What is subnet? Yes. Quickly, everyone. I have written count is equal to 2. What is the meaning of 2 subnet? From that, we can get IPs. Fine. So subnet, just go after the name. That will help you out to remember things in a better manner. Subnet means, I mean, like sub of network, right? Sub of network. So you can think in this particular manner so that you can remember it for the very long time. So what subnet? Because all of these services are available in every cloud provider, not just in AWS. Go to Azure, go to GCP, go to Oracle, everywhere it is the same thing. So because this is how the entire internet on cloud works. So subnet simply means that when I say count is equals to 2 inside a subnet, it simply means that let's say I'm trying to host my application. So I'm trying to host my application in Mumbai. Now let's say the entire Mumbai region is down. So obviously I will not be able to access my machine, or I will not be able to access my application. So this is where subnet comes into picture. So basically, as we are using a application load balancer, so whenever user will come, it will not hit my machine directly. It will hit basically my load balancer. Now load balancer will decide that shall I send a traffic here or maybe somewhere else. This is what load balancer is going to decide. So let's say my Mumbai region is down. So it will start sending traffic to a Hyderabad region or maybe a Singapore region, let's say. So this is where my subnet count is equal to 2 comes into picture. So it is going to make my application available into a two different availability zone. So this is where we have written availability zone is equal to data availability zone available name and then count indexes. So give me two at least availability zone, count index, two availability zone. Just try to give it to me so that I will be deploying my application into two availability zone. So whenever one will be down, load balancer will send a traffic to the another one so that my user will never receive any kind of a disturbance. Otherwise, if I'm not going to do a subnet, let's say if I'm deploying only in one region, do we need load balancer, guys? So technically, load balancer need at least two, right? Two. Okay, now. So ALB is fine, BPC is fine, ALB is fine, subnet is fine. Now we are able to understand all of these things. Now there is something called as routing table, again, very generic one, right? So what routing table does? So basically, routing table, whenever some traffic will come, so routing table is having an idea that, okay, so where I have to, send the traffic. So it is going to send a traffic with the help of routing table that you are going to maintain and manage. So this is what we are trying to maintain it inside the routing table. Routing table association again, so same thing. So how routing table will be associated with each and everyone. So we are trying to take care of that. Then security group. Again, important and very common part you will be able to find out. So here Security group is basically going to behave as a firewall, a kind of a wall for any kind of a threat, any kind of a attack, because you are trying to communicate with the internet. Even you are communicating internally, you are trying to like give an access to a user, obviously via ALB, but yeah, so you are trying to give an access to the user. So basically here, what will happen, let me give you one example. So let's say I have a ALB, as you can see even here. So let's say I have a ALB, right, a load balancer. So user will come, so they will hit my ALB, by the way. So once they are going to hit a ALB, so I'm going to basically allow traffic only from, let's say, port number 80, not from any other port. I'm going to basically allow it. And then maybe I'm routing to something, something, something. So all of these things will be maintained and managed inside, or like who is allowed, who is not allowed. Everything I'm going to maintain and manage inside a security group. So here ingress, I think I have already told you about a ingress when I was talking about even a Terraform. So ingress is nothing but HTTP, HTTPS. So like connection, communication, traffic. It is you can define inside the ingress. So here ingress description, production traffic from port 80 to port 80, protocol TCP and CIDR block. So IP addresses basically. So this range. So this is basically a definition I have given for this particular security group. Now, for like ingress green test traffic. So whenever I have to test it, so I will be testing my green line on 9000 port number, production on 80 port number. Egress, so basically from port 0 to port 0, this one. So now in this way, I'm trying to basically create a security group for ALB I have created. Now automatic load balancer, which is a first like a point of contact for my user. Now security group for ECS. So this is my actual like a resource, right? So who will be allowed, who will not be allowed. So my ECS can't be accessible via user. So my ECS can be accessed only by my load balancer. User will access load balancer will access ECS, right? So that's a security group that I have to provision, and this is what we are trying to do it, right? That from container port this TCP port, and only security group this is allowed to get into this one. And then we are trying to define like all this port which is open, which is closed. Then basically AWS LB main. So here again resource wise. So AWS here we are creating what? So we have ALB. Load balancer is done. ECS. Fine. Security group ECS is done. Then we are trying to configure blue green. So AWS LB is fine. Then target group is fine. And target group wise, we are trying to target blue port. Fine. Okay. So here we are trying to in configure the resources, which is LB target group. So target group is obviously like blue. Fine, target IP address. Okay, so here we are just trying to create the resources, so which is going to basically like target my final blue line where like I'm running my container. That's it. Now health check wise, so path, matcher, interval, timeout, all of these things will be used for the health check. So whenever it will be doing a code deploy. So I told you about the code deploy. Now same thing we are trying to configure it for my green, the one that we have configured for the blue line, and then ALB listener a prod. So for our production, so final port is going to be 80. All of these things we have defined. Fine. Then listener, and then there is a test environment. So this is where we are configuring my test environment. So I told you that it will migrate from my test to a production. So via green line basically. So we are defining that one over here. AWS ECR repository. So what will be the repository that we are going to create? So there will be repository with the name app. That is something that we are going to create inside the ECR. Then CloudWatch log group. So again, from an app, it will be able to get all the logs. So AWS CloudWatch services. Okay. Now So here ECS execution. So from where it will be able to pull the images. So this is what we are defining in this particular place. And then here, so we are trying to define the policy. That's it. Resource policy wise, that who will be able to access and what that particular one will be able to do it with respect to the IAM. So if IAM role is equal to code deploy, so they will be able to use this blue and green line and they will be able to deploy it. So these are just a policy attachment again, which is going to come in every places. Then here, so we have basically a GitHub action. So whenever GitHub action will be called, and then GitHub action will try to hit your AWS, then what is going to happen for a blue line as well as for a green line, and what and all things will be called one by one, one by one. Then ECS task definition. So this is how this entire file is been configured, guys, and you can try to use it as a template, by the way. And with the help of this file, we are trying to configure my entire infrastructure. Before that, I would like to tell you one thing that we are trying to configure infrastructure. That's completely fine, but there is something called as estimation, right? So there is something called as infra planning. We try to do a infra estimation in a first place, that this application is going to need what kind of infrastructure, what kind of resources it is going to need, what kind of a storage it is going to need. That is something that we are not doing over here. So we are not doing infra planning over here. Directly we are trying to create a small infra, so that end to end we can understand how infra will be created, how infra will be spent. So fine, this is my main.tf. Then the most important part is monitoring. So here, CloudWatch, only CloudWatch, basically. So in a production, it is going to do each and everything for you, and that is going to be my CloudWatch at the end of the day. For creating a matrices, we are using a CloudWatch. For basically errors, we are using a CloudWatch. For logs, we are using a CloudWatch. So for everything, we are trying to use basically a CloudWatch itself. So everywhere CloudWatch, ALB latency, right? No healthy targets. So all of these resources we have created. If CPU consumption is high, capture that one as well. App error line. So each and everything I will be able to capture it inside the CloudWatch. Now, only these two files. Rest is just a variable, and then version wise, we are just trying to maintain the version, that what is the Terraform version I'm trying to use, AWS, all of these things. And for AWS, all of these things are pretty much standard. Now, once Terraform will be done, you should understand one more thing. So that thing is basically deploy.yaml file, because this is the file which is going to help me out in terms of configuring the final deployment. So which exists inside my .github folder, that what GitHub is supposed to do. So here I'm trying to build a deployment, blue-green deployment. Now, how my three branches are going to behave. So this is where I have defined how my dev branch is going to behave. So basically, run the test, build the image, nothing deploy. I think we have discussed multiple times. This is what will happen inside the dev branch once this action will be called. Then test branch. So deploy to AWS, verify on the green listener 9000. Then main branch, which is a production branch. So basically make it live at port number 80, automatic rollback if there is some failure at any point of a time. So here we have written a deployment file, deployment YAML file. So we are trying to push these things to a branch, dev, test, and main. So there will be three branches, dev, test, and main. Pull request wise, so we can try to pull it from a test, or we can try to pull it from the main if there is some like a discrepancy in between. And workflow dispatch after that. Environment wise, so AWS region, I'm going to set US East 2, ECR repository, blue green, ECS cluster, because everything will be done by whom? By basically like a GitHub action, right? So GitHub action is going to call each and everything. So ECS services, this one. So I've given the name, by the way, container name app, code deploy app, blue green app, code deploy group, blue green deploy, ALB name, blue green, this one. Okay. App color is equal to blue. Permission, ID token. So write and a read permission I have given basically, so that it will be able to log in into my AWS. Now jobs wise, so what I'm going to do. So job wise, I'm going to basically call a test, right? Whenever it is going to pull something from one to another branch, maybe from my dev to test to production branches. So here, basically Ubuntu latest, it is going to spin a small machine inside the GitHub action, and then it will start calling all of these things. So first of all, it will start install the dependencies, then pip install this, and then build the final images. Now, deployment wise, so deploy to AWS wise from test. So GitHub event name push, and if it is going to be test or main, so in that situation, what it is supposed to do? So name this environment ID env and then try to do this one. So technically, what I'm trying to do, so I'm trying to define that what should happen in dev, what should happen in test, and what should happen in technically main. So whenever something will come inside a dev, then what action I'm supposed to call. If something is going to come inside my uh, test, then what I'm supposed to call, and everything is been written as a logic in this one. So what I'm supposed to basically run at any point of a time. Fine. So this is something that it will do, and then like if it is a production, then push it, download the current task definition. So this is what my GitHub action is going to do continuously, and after like making it live, so even try to test it. Now, so this will control my GitHub action so that from GitHub it will start doing a deployment on a AWS. Now, testing. So every time I'm talking about testing, right? So test an app. What we are trying to test over here. So we have an endpoint. Let's say we have a health endpoint. So with the help of code, PyTest basically, I'm trying to basically test whether this endpoint is working or not, 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 and all of these endpoints are my own endpoints, right? So here inside app, inside main, the other endpoint that we have defined health endpoint, app API info endpoint. All of this endpoint is my endpoint, right? So home endpoint. So I'm just trying to test only that endpoint. So test case wise, we are not writing anything very different, by the way, right? I'm just trying to basically test my own endpoint. If status is equal to 200, test pass. If status is not 200, test fail. Likewise, we can try to write any number of a test. So this is a whole flow at the end of the day. Make sense, guys, to all of us? Yeah. Then I have written deploy and destroy basically command. So what this does, so this is just a like a script that has been written. So let me tell you what it does, by the way, starting from like a deployment till a destroy. So check your tools and your AWS GitHub logins, runs the test locally, create a ECR registry, build and push the image, create all the AWS infra, tells GitHub which role to use, commit and push to main, watches the GitHub action, watches the blue green snap, smoke test, and then print every link you needed. So this is what this entire script is going to do one by one, one by one. So basically it is going to fire the entire things from your local to your infrastructure so that in one go, everything will be set for the very first time, right? Just in one go, everything will be set automatically for the very first time. So this is what it is going to do, guys. You just have to provide your AWS access. So now let's try to execute it and let's try to run it. Let me show you the run for this one. So let me go and create a new repository. Blue, green, test, let's say. Okay. Let me make it public for now so that I can share the same with you. Okay, so now I just have to push my code in this particular place. And once I'm going to push the code, everything should be up and running and working. Sir, are we managing env variables and secrets key etc? For this project, we are not managing any kind of an environment. Yeah, we are going to basically, I'll show you this one. Once I'm going to do AWS login. So here, let me do a login in my AWS. So we are just going to maintain manage AWS IAM secrets. Otherwise, we are not having any API because it's a very simple application that we have created, right? But I'll show you where to store. There is something called as like a credential manager. So over there we can store it. Let me log in to my AWS. So so in next 15-20 minutes at max, the entire things will be deployed. Okay, so basically, last time I have shown you that just go and create a IAM user. So I have my own IAM user, right? And I have already created that. And then what you are supposed to do? So go to a security credential after creating the IAM user, and that IAM user must be having admin access. So basically, if you're the admin, if you're doing it for the very first time, so let's say I have a admin access for this IAM user, and then security credential wise, so I can try to go and I can try to basically create one new access key from here. So I already have a one access key which I have created, right? So I can try to use that particular access key as well. Make sense, guys? Yeah. So IAM access, IAM user, I have already told you. I already told you how to create IAM user. So, and then, just to try to create the security credentials. So you will be able to create access key, and then that's the only thing which is required in terms of doing a deployment. Okay. Now, where you are going to store those security keys. So basically, you can go here, you can go secret and variable, and then you can try to basically call action over here, and then here, so you can try to call a repository secret key, and then here you can try to basically create a new secret key. So here you can try to give your own like a secret name, and then you can try to give a respective values in this particular place. Make sense? Yes. So let me set that up. Let me set my key for this one. From my previous run I have already done that, but yeah, for this run let me set my secrets. Just to give this, I'll show you the final name, but can't show you the secret. Access ID. Hmm. Okay, so it's done. So basically, what you are supposed to do, so basically, you can try to come to a secret and variable inside a GitHub, and then action, and then inside that repository variable wise. So I can try to set these variables in this particular place. Oh, it's visible. Let me rotate it quickly. Okay. So yeah, that's a place where you have to create it. I'm going to delete this one. Reason is very simple. Reason is that it's a production environment, so can't take a risk. Deleted. Let me create a new one. So okay, so my GitHub is done. Now let me. Everything is done. Now we can run the things. Okay. So here, basically, what I'm supposed to do. So when I will try to push the entire code base. So one thing I have to change a GitHub repo. So this is my previous repo. So where the repo name was Euron Tech and then a blue green. This time the repo which I have created is basically Euron Tech inside that blue green test. So I will just try to replace this name with this one. This one. Yeah. Rest is completely fine. So I don't have to replace anything by the way. Only this much have to change, right? And once this is done, then let's go and let's try to basically connect my remote repository just for once. So I just have to add this origin because my previous one was different. So add this origin already exists, blue green test. Oh, so I have to basically delete the origin. Git remote remove origin. Git remote remove origin. Fine, done. Add the same, done. So my origin is added by the way. Now I don't have to do anything. So now everything will be taken care by my deploy slash ps. Very, very simple. So I have dot slash deploy ps1. So now it will start doing all the job. So it has failed. AWS string get call identity profile address profile output. There is some issue checking your machine, your AWS login and your GitHub login. Okay, so inside my AWS CLI, I have to provide. Let me check. So let me set my key here. CLS and then blue green test. Access key ID. Region name US East, let's say 2. Okay. So just 1 minute, guys. Facing an issue with respect to our connectivity. It will be fixed in like 5 minutes max. Okay, so yeah, issue is fixed. I'm able to log in my AWS, and now it will start like doing everything one by one from my GitHub to uh, AWS, all the places. So I'll show you my AWS in some time and GitHub both. Okay, so pushed. So this is how easy it is, guys, in terms of deployment. The full automation, one sort, and everything done. I mean, with like any number of machine, even thousand number of machine, I have to maintain and manage. Any big, small infrastructure, I have to maintain, manage. Maybe AWS, Azure, GCP, or maybe just my custom own company owned infrastructure. I can do everything basically. I can automate everything technically. So you have to wait for 10, 10, 15 minute. On an average, 14, 15 minute it takes. So you have to wait for 14, 15 minute. It is going to create my VPC, my ALBs, my subnet, my security groups. It is going to create my policies. It is going to create my routing table. It is going to create, and after creating everything, ECR, ECS, and then pointing to the cloud watch. So I can go into a cloud watch, and then I will be able to see all the logs. Done. Can't we have a dedicated session for CI/CD? We are doing CI/CD, right? CI/CD via Terraform. We are doing it. Last run command, please. So there was no command that I have run in a last. So I have already created this deploy.ps1 power cell command, and yeah, so like everything is there. So connecting to a GitHub, checking all the credentials, and then connecting to like a GitHub will connect to the AWS, and then from there it will do it. So yeah, it has committed everything to my origin main. It looks like now I can go and I can check my GitHub. Yeah, so it's CI/CD only. Exactly. So the things that we are talking about is what? Continuous integration, continuous deployment, right? So after this, if I have like, if I'm going to change anything, right, from here to GitHub and automatic, I'll show you GitHub action as well. So everything is here. I mean, like I have written everything, and again, my entire pipeline is going to work as per my deploy.yaml, the workflow inside a GitHub action that we have written. And Terraform is basically helping me out in terms of maintaining my infra with code. This is why that's the reason we have discussed Terraform in my last class, right? So last class I was trying to maintain resources of my local system with Terraform. This time Terraform with AWS. So refresh and yeah, so main branch is been created. I can try to come and create other two branches as well. Everything is available here, guys. So now you can take a pull, deploy via deploy.ps1. So take a pull, everyone, from this one. So most of the thing will be same for other type of deployment as well, right? As we can see, deployment is not going to be same for everything. For example, I have not configured databases over here. Again, multiple different kind of a database I can provision from AWS, maybe from some other provider, or maybe my own hosted database on AWS or somewhere else, plus a cache, plus a CDN, right? Plus a domain mapping by using a Route 53, and basically, you know, uh, first of all, infrastructure planning. So let's say I have to spin maybe Kubernetes services with 100 number of machines. So first of all, deployment comes from the architecture. So first I do architect. So we design the entire architecture, and then after designing the architecture, so we basically write this Terraform file. So as of now, it's a like a deployment with ECR and all the across services. Security is going to be very common. ALB is going to be very common. VPC is going to be very common. Subnet is going to be very common. Policies are going to be. So yes, whatsoever now you are going to do it, it will be an addition on top of this. Very, very simple, right? For example, if I have to manage hundreds of GPUs, right? H100, or maybe something I have to manage, maybe 39, itself I have to manage. So obviously I have to configure as per that one. Okay, now I can go to this one and I can go to my ECS basically, and then I can try to check so whether it has created, and it should be in a East 2 I have given. So I'll check in that region. So yeah, blue green cluster two is running now. If I'll go and click over here, so blue green services, it is trying to run. So this is the service, guys, and two cluster it is trying to run as of now. Right, two out of two task is running. Task definition is there, and you can go and you can try to investigate. So what is running, what is not running at any point of a time, and it looks like it's a healthy one. This is my service ARN, by the way. Yeah, so now I'll show you even a cloud watch. So here, cloud CLOUD, cloud watch. So here it is going to show the entire logs. Hmm. So application load balancer, blue green slow response, blue green CPU high. So yeah, it is showing me some logs just like Grafana. So basically this is behaving like a Grafana. I can click on this dashboard. So it is trying to create two dashboard, one for ECS. So where I will be able to come and check. So consumption, CPUs and everything. And then there is a blue green overview, like as a whole, like traffic, latency, this, all of these things. I'm able to see it, and which is happening in a real time. So fine, take a pull, guys, from here. Now, so this is my cloud watch. Let me open up in a new tab. I'll show you all the services one by one that we have configured. So ECS is fine. So here is our ECS. Then we have basically a ECR service that we have used from here. So ECR. Elastic Container Registry, so which is going to hold my container. Then let's say we have configured my VPC, so I can show you my VPC as well. Then we have configured basically my ALBs, so application load balancer. ALB will be available inside my EC2 right hand side. So load balancer, and then inside this, it is going to show me my load balancer. Yeah, so blue, green, A and B. So this is basically a ALB that we have, and inside that, so we have basically a blue, green, and this is green, and this is basically blue. So this is basically pointing to a final user at the end of the day. Makes sense, everyone? Yeah. So it is pointing to from a US East to A and 2B. So there are two container. My ALB is trying to handle, which is like a mapped to, I would say, right? And yes, so at port number 8000, it is trying to basically do it. And it is basically mapped towards one of the PPCs. So my ALB is fine. Load balancer, by the way. VPC, so you can go and check all the VPCs. So here is a VPC that we have created for my blue green, right? So which is going, and again, subnet you can go and check container wise. So yeah, blue green container we have created. So you can say this is my latest one which I have created. ECS wise, so this is my cluster which is like up and running, right? So yeah, I'm able to see my cluster over here in this particular place. Any question so far for me? This is also fine. So yes. So ALB, I can go here. Where is my ALB? Inside EC2. Load balancer. This is my DNS name. So fine, blue, green, this, ES2, this one. Okay. So technically, I must be able to access my page at this particular place. This is basically my DNS name of my ALB. So load balancer, and there are two DNS. Let me do 9,000 as it is being served at 9,000. It is not giving me. Let me check my ALB. Security group is this one. So port range 80 is given, production traffic. So yes, it must be. So application is up and running. I'm able to see that inside my CloudWatch. The only thing is that I have to just check the security, basically the inbound one, whether I will be able to like send a traffic or not. So security group for blue green is basically this one, or I can say this same thing. Let me check the security group. What is the security group? So HTTP, custom HTTP, TCP, this one, and the source port. So this is my inbound. So anyone can come to 80, anyone can come to 9,000. Yeah, so this also looks good to me. There is some issue. Ideally, this URL should, okay, there is a HTTPS. Service is temporarily unavailable. Cool. 80. Yes, guys. Actually, it was working. So by mistake, the URL which I was hitting, right? So my Google Chrome was taking like a HTTPS. That was the only issue. There was no other issue. Everything is set because even in my ALB, I have already checked. So inbound traffic wise, security group wise, so it is allowing like a 80 and 9,000. So which is like fine inbound traffic wise. It's already set. So everything was set fine. Nothing, but just the way I was hitting was different. So yeah, I mean like this is available, which was working in my local system. So now even you can check, do not use HTTPS. You can just use HTTP. So I have just pinged you the link. Rest of the endpoint I will be able to check. So I have created what? I have created so many endpoints. Let me open up my application. So blue green app, and then main.py file, and then here. So I had a endpoint, right? So I had basically health endpoint. So I can check this health endpoint. What it is trying to showcase. Maybe I can check that. Health. So fine, health is fine, like healthy. My blue is live, and along with that, so I can try to check even API info. Before that, let me write it down here itself. API slash info info. So yeah, everything is like fine even over here. Swagger UI also I'm able to load. So health API info from here also I will be able to test. So yeah, all the endpoints I can test it from here itself. A blue green demo, right? So everything I can test it from here. So everything is up and running. I can go to my dashboard and I can try to refresh it. I will be able to see some new data over here. So yeah, there's no traffic. So I'm able to see some new data as well inside the dashboard. So this is this, guys. Now we are able to do a complete like a deployment. Everything is done. All the services we are able to set, and everything I will be able to check, manage, monitor, whatsoever I want. I can simply like do it. You know, matrices, everything I will be able to check it, and then I will be able to create a alarm as well from here itself. So now finally my application is live in a automated manner. Now I have to destroy all the resources, every resources that we have. So let's try to destroy it. So here inside this one, I have already mentioned the destroy command. So simple call this one, and what it is going to do. So whatsoever resources it has occupied, it is going to destroy it. So not just you are trying to control, building the resources, but you can also control the destroy. I mean, like you are controlling technically the whole resources, right? So whatever you want, you can try to do with those resources, and in that manner, so I will not end up burning my money. Oh, caller identity. So basically, I'm going to destroy it with AWS PROFILE profile glow green test. Use this credential, destroy everything. Type delete to confirm. Delete. So it is going to lead my load balancer, ECS, ECR, logs, everything it is going to clean. And yeah, so I will not end up paying $0.05 per hour because the infrastructure which I have spent and the services that we were using. So actually it was, I've calculated. So it was costing me around $0.05 per hour. Basic infrastructure, right? So now it will not cost me that much. Able to hit app? Okay. Can we use the same code for deployment in our AWS? You can use anywhere now. Anywhere means literally anywhere you can try to use it. Just come over here, change a GitHub repo name inside your CLI. So try to just log in AWS CLI, set your IAM credentials, secrets and name. That's it. Done. Apart from that, you don't have to do anything. One hit and everything will be live. Make sure that your IAM must be having a admin access, or if not admin access, then whatsoever services that you are using on top of those services, so your admin must be having a read write access, read write execute access. So I'm a bit confused on using release pre-prod use case during deployment. Explain where we can use this envs, and when see, the envs are technically for a local. When you are trying to do a deployment in a local, but let's say I would like to access a production database, or maybe not production database, let's say dev database I have, but database obviously you will not keep in a local system, right? From a day zero itself, when your team will start developing something, your database will be created, maybe a small, with a small instances, a dev database you are going to create. Let's say you are going to use OpenAI key, Anthropic key inside this one. Let's say you are trying to integrate a WhatsApp services. So obviously, your API key for a WhatsApp, anyone is a provider. So you have to basically configure that one. Let's say for payment gateway. So obviously you will be having a dev credential for that one. So you are creating, building, testing something in local, but technically you are trying to use something which is not local, some other different platforms. So in that situation, from where you will be able to access a credential, so that's the reason in a local we try to create a envs, and so that I will be able to log in. So just like I think I have shown you that multiple classes as well, right? So if I have to access my databases, so I can try to give a API string, connection string, and API key for that one, that I can keep it inside my envs. That's it. It will be able to read it. And when it will go into a production, so at that point of a time, it's a secret manager, so where we try to store it. So envs are for local development. Any other question, guys? Yes. So there is something called as candidate deployment. There is something called as just a Docker-based deployment, just a Kubernetes-based deployment, just a Terraform-based deployment. Then Terraform with Docker, which we have done. Terraform with Kubernetes also we can do. So now, if I have an architecture of an infrastructure, right? So within like 10 minutes, I will be able to modify my Terraforms with that architecture exactly, right? And yeah, so my entire infrastructure will be ready in 5 to 10 minutes. That's it. But like I said, guys, everything comes from a planning, infra planning plus architecture. So first you have to focus on that. Maybe if you have a clarity on infrastructure planning and everything, then code will be produced by AI. But that planning, obviously, you have to do it alone, or maybe with AI, or maybe with a team. So fine, everyone. If we don't have any kind of a question, so hope all of you have enjoyed this class. I have also given you a GitHub link, so please go and take a pull from there if you want. Same code will be uploaded even inside your dashboard. Yeah, so it is like deleting each and everything. Cool. So it is destroying my resources. Sir, which reasoning model is best currently? See, Cloud model is the best in a market as of now. You can also try Kimi 3. Basically, Kimi is getting a lot of popularity because of their pricing, and they're close to this one. Yep, deployment demo. Yeah, in your Super 30, I'll try to explain you in more detail way. We'll discuss multi deployment strategy. Not just, this is one of that. Okay, fine. Thank you so much, everyone. Take care and see you again. With capacity planning, exactly. Yeah, capacity planning is very. I mean, like that's a starting point. Capacity planning, then architecture, then deployment comes into picture, right? So we'll do it there. Okay, fine, everyone. Thank you so much. In my tomorrow's class, I will be talking about GPUs and how we can try to configure a GPU. I will be using HyperStack. So HyperStack is a GPU provider. So I'll be using that, and we'll try to spin a GPU H100. They also provide you a Kubernetes cluster managed, I mean, like case managed GPUs, so where you can spin multiple GPUs all together. You don't have to manage anything. You just have to do kubectl. That's it. The one that we have already discussed. And yeah, so you can use those GPUs for a training or for a inferencing. So I'll be showing you those things in my tomorrow's class, and little bit of LLM ops. Next week we'll be talking about a ML ops part, the operational part of like inside a ML. So data versioning, model versioning, all those things. Yes, Manish. Yeah. So I believe agenda for tomorrow is clear. So with that, thank you so much, everyone. Take care. See you again tomorrow. Thank you so much.